Hi everyone and welcome to this third video on the hardest GCSE problems of all time. Now this one's particularly difficult. It's so difficult that less than 10 people in the whole of the UK taking this exam actually got it right. That is really very difficult. And it's a vectors question, and I'm going to presume you have some knowledge about vectors, otherwise you're going to find this particularly difficult. So I'm not going to go through all the vectors from scratch, but I'm going to tackle this particularly difficult problem. So let's read the problem. We've got OAB as a triangle, we've got OPM is here, that's a straight line, and APN, that's also a straight line, and M here is the midpoint of A to B. We're also told that OP to PM is 3 to 2, and we want to work out the ratio ON to NB. So we want to work out this ratio here. Now it looks like that N is a bit less than halfway, so this ratio could be, I don't know, 1 to 2 or 2 to 3 or something like that. It's going to be slightly less than halfway. So how do we tackle this problem? Well, firstly, I would just kind of write the information that we've got in the question on the diagram. So we've got O to A is A, let's put that in. We've also got O to B is B, let's put that in. We're also told the ratio of OP to PM is 3 to 2. I tend to like to write the ratios in my vectors questions. So we've got that information. And we're trying to find the ratio of ON to NB. So ideally, we want to find out what the vector O to N is, this vector here. Because if we did, then we could work out the ratio of this to this, because we could see what fraction of B just O to N is, right? Now, in this difficult kind of problem where you can't directly work out that vector, what we can do is to get from O to N, we can consider two different routes we could get there. So we could just go directly from O to N like that, or we could go more indirectly where we could go up here from O to A and then come down to here. Either way, we end up, we start with O and we end up at N. So let's try and find those two different vectors and then let's see how we can somehow compare them to work out the sort of unknowns that we have here. So let's start with O to N using the yellow route. So O to N, well, we don't know what fraction, it's some fraction of B, but we don't know what fraction that is. So what we're going to do is we're going to introduce something called a scalar. Now, scalar is some unknown, well, it doesn't have to be unknown, but we're going to introduce an unknown scalar, some unknown multiplier of B. And I'm just going to call it lambda. It's just a particular Greek letter, but we could just use a normal letter. So we know that O to N is some fraction of, so theta is the fraction we don't know, some fraction of O to B, right? Now, we could have also, so that's a yellow route, by the way, that's a yellow route. Now, the purple route we could find O to N going using the purple route. Now, to do it via the purple route, we're starting at O, we're doing a vector A, so let's put the A in, so it's A plus something. And then, so we're going O to A, and then we're coming down this way. Now, we don't know what the vector A to N is, but it is actually possible to find out what A to P is. Because to find A to P, we could start A, we could come down here, which is going to be a minus A, and then we're going to go this appropriate fraction, using this ratio here, this appropriate fraction of O to M. And we can work out what O to M is without too much trouble as well. So what we're doing is we're going from O to A, that's a vector A, and then we're going to do A to P, but then we're going to scale A to P, so we get from A to N instead. Remember, if two vectors are parallel, one is a multiple of the other. So A to P is parallel to A to N. So we can say that A to N is just some multiple of A to P. It's just scaling it in the same direction, it's just making it longer. So let's do that. So we've got A plus some multiple of, we're going to just have to introduce some algebraic constant, we don't know, let's call it mu. So mu is just a Greek letter, some multiple of A to P. And I know this is difficult already, it is a very difficult question. Right, so we now want to work out what A to P is, so let's think about that. To work out A to P, well, to get from A to P, we're going from A to O first and then O to P. To get from A to O, we're going backwards down A, so it's going to be minus A. And then to get from O to P, it's going to be some fraction of O to M. What is that fraction? Well, this is 3 to 2, so the total number of parts is 5, and we're going 3 of those 5 parts across. So therefore, it's going to be 3/5 of O to M. And again, we need to go further because we don't know what O to M is. So how do you work out what O to M is? And that's a more typical GCSE vectors question. To get from O to M, well, we could go from O to A and then A to M. So let's write that in. It's 3/5 of, I'm going to leave a nice big bracket. So I said to get from O to M, we're going from O to A first, we're going A. So we've got from O to A, we've done an A, and then we want to get to M, because remember we want to go from O to M, we're going A plus half of whatever A to B is, because that's A to B, and we're going halfway across. So it's going to be half of A to B. And now we have to work out what A to B is. But A to B is relatively easy. To get from A to B, we could go this way and then this way, couldn't we? So it's minus A plus B. So let's put that in. Plus half minus A plus B. Let's close that bracket, that bracket, that bracket. And now we just need to kind of expand and simplify, and then we're on our way. So let's just expand out the inner bracket first. So we got A, half times minus A is minus half A, and half times B is plus half B. And then let's just collect like terms inside that bracket. So we got 3/5 of A minus half A is half A. So we've got half A plus half B. And now we can expand out that other inner bracket. So we've got mu minus A. We've got 3/5 times half A. 3/5 times half is 3/10. So we've got plus 3/10 A. And we've also got 3/10 B. Now we can collect to like terms inside this final bracket we've got. Minus A plus 3/10 A. Well, minus 1A is minus 10/10 A, plus 3/10 A is minus 7/10 A. Got 3/10 B. And then finally, we need to expand out this final bracket. So we've got minus 7/10 mu A and plus 3/10 mu B. So finally, we've got an expression for O to N using the purple route at the top here. Now, O to N, whether we go the yellow route or the purple route, we end up in the same place. We start in the same place, we end up in the same place. So those vectors must be equal. O to N is O to N, regardless of what route you go. So that means we can set them equal to each other. So let's do that. We've got lambda B is equal to the purple way, so that's A minus 7/10 A, mu A, sorry, plus 3/10 mu B. Now, where do we go from here? This is where it gets a bit complicated. Well, the amount of A and the amount of B we have on the left and right hand side of this equation has to match. So what we can do is we can do something called comparing coefficients. The coefficient of an algebraic term is just the kind of constant on front of it. So for example, if we had 3x, the coefficient of 3x is 3. It's the number in front of the x. And same here, the coefficient of, for example, this lambda b, well, the constant in front of the variable b is lambda. So the coefficient of lambda b is lambda. So we're going to compare the coefficients of A and compare the coefficients of B. So let's compare the A terms first, the coefficients of A. Now, we don't even have an A term on the left-hand side, so I'm just going to write in 0A to say we have 0 lots of A. So let's look at the coefficients of A. I'm just going to highlight these. We've got 0 lots of A here. Well, we've got 1 lot of A there, so let's just make that a 1. And then we've also got minus 3/10 mu lots of A. So let's compare those coefficients. We've got 0 is equal to 1 lot of A minus 7/10 mu lot of A. And we can solve this equation to work out what mu is. So I could just times both sides by 10. So that's going to be 10 minus 7 mu. Can add the 7 mu to the other side. And that means that mu is 10 over 7. So we've worked out what mu is. And in fact, we could sub in the mu into this expression here, because there's no lambda, just mu. And we can work out what O to n is. Or this expression might be simpler, so we could work out what lambda is. So let's compare the b terms. So comparing the b terms. Now, what have we got of b on each side of this equation? We've got lambda lots of b, and on the right-hand side, we've got 3/10 mu lots of b. So we can therefore say that lambda is equal to 3/10 mu. But we know what mu is. It's 10/7. We just worked it out. So it's 3/10 times 10/7, which is 3/7. So we've worked out that mu is 3/7. So if we go back to the top, then we can say, well, this lambda b is equal to 3/7 b. So if we put that on the diagram, this vector here, just O to n, is 3/7 of b. So what we're saying is that to get from O to n, it's 3/7 of the way along from O to b. And then we can easily turn this into a ratio, because if this is 3/7 of the way, we could split this in the ratio 3:4. The reason 3:4 works is because then, if we're going 3 parts along of the 7, then we've gone 3/7 of the way along. So the final answer to this problem, the ratio of ON to MB, is that ratio is 3:4. And that is the final answer. Please do like and subscribe if you like this video.